Hi there and welcome to learn2creategames.com. Today we'll have a look at C#, arrays and loops. So let's get started. So first we'll create a brand new project. So again, I'm sure you can do that. And whenever this project is created, we will create a ground. And the idea will be to generate a few boxes, but using a script. So first we create a brand new cube. And then we will just resize it on the X and Z axis. So again, we'll have a rescale of 100 on the X and a rescale of 100 on the Z axis. So once this is done, we're going to create a material and then apply this material to this box. So again, we can go to create, then material. This will create a default material. Then we can change the name of this material to green. And once this is done, just change its color. So again here, using this window, you can just select green and then take this material and drag and drop it onto the ground. So this is relatively simple. The next thing we need to do is to create another object that we will use to instantiate walls. So again, we're going to do create, 3D object, and cube. So by default, this cube is a 1 by 1. So again, the size is 1. And we're going to change its name to wall. So again here, I'm going to press on Shift and F to focus on this object, then move it up a little bit. And then what we'll do is just change its color. So again, I'm going to do the exact same thing. I'm going to create a brand new material and apply it to this box. So again, I'm going to duplicate the existing material using Apple D or Control D, then rename it, and then go to the option for the color and make sure that we choose a different color. So again, here I'm going to choose something that will be blue. So when this is done, of course, I will rename this material to blue and then drag and drop this material onto the box. So again, the box becomes blue. So again, very easy so far. So at this stage, what I'd like to do is to create a prefab with this box. So I'd like to instantiate it several times. So to do so, I will need to transform it or to convert it to a prefab. So prefab, again, is a little bit like a template you could reapply or reinstantiate later on. So once this is done, I can deactivate my box because my prefab has been created. And I can get to start coding. So before I code, what I will do is create an empty object. And this empty object will be used to be attached to the script that I need to run. So again, I'm going to create this object and rename it create world. So again, there is nothing in this object. It will be a container for our script. Then I will create a script. So it's a C# script and rename it create world. That's something you might know. So again, the name of the script is the same as the name of the class that is created within the script. You can see it on the right hand side. So when this is done, we're going to do a few things. So the first thing we'll do is try to create a little loop, and this loop basically will instantiate the box so that it creates basically different rows, a row of boxes to start with, so one row. So again, actually this variable will not be used for a little while, but just to know later on we will use it as an array. But the principle really here will be to create a loop that will go from 0 to 9, so 10 elements in the loop. And then what we will do is we'll instantiate 10 different boxes, okay, based on the loop. So again, the idea is to instantiate different objects, but make it easy for you. So again, using a loop, it will be much easier than creating them yourself. So again, we're gonna just finish this line and move on to the loop section. So once this is done, in the start function, what we will do is create the loop. So again, for our loop, we will need several variables. One of them will be the object that we need to instantiate. So again, I'm going to create as public because we will need to access it from the inspector window. So again, the type is public, the name is wall, and then what we will do is create our loop. So again, for our loop, we will use a counter called I, so it's an integer, and this counter will start at 0, will be incremented by 1 every time we go through the loop, so I++, and then the this element I will be less than 10. So basically we're going to go from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so again, this is our loop. And within our loop, what we will do is just instantiate a wall. And the wall will be instantiated based on the value of I. So again, we're going to instantiate. To instantiate, you need 3 different values. The first one is the element you want to instantiate, so the game object, which is the wall. The second one is a position that is usually, I suppose, referred to using a vector tree. The vector tree will provide you with the x, y, and z coordinate. So in our case, the x coordinate will be 0, the y coordinate will be 1, and the z coordinate will be, I suppose, I multiplied by 2. The idea here is that, let's say, for the first element, it's going to be at the position 2, 1, 0. The second element would be at the position 4, 1, 0, and so forth. So again, just to add a bit of space, if I'd removed the number 2, there wouldn't be any space between those boxes. So once this is done, there are a few errors that we need to correct, and those actually are quite interesting. You might actually face them as you actually are coding. So again, the first thing is that I actually forgot to add the third element, which is the rotation element. So again, we use quaternion.identity. Like quaternion, the u should be lowercase. So again, we have another error. So again, quaternion.identity means that we will not rotate our object. Okay, so again, identity means that nothing is changed. So again, when you instantiate, the first element is the object, the second element is the position, and the third one is the rotation. So again, we have another little thing to modify here, is that identity should be I lowercase. So save. Okay, and the last thing is a conversion. So you actually might come across that a good few times in C#. Basically, what is on the left-hand side of the equal has to be of the same type of what is on the right-hand side. Because of a game object on the left, we should have a game object on the right, which means that using the game object within the round brackets, we will do what is called casting, which means that we will convert the type to game object. And then Unity seems to be happy with that. So again, we need to take this script and drag and drop it to the create world empty object. The last thing I need to do, and that actually you have an error here, and needed to instantiate the public variable for the prefab that needs to be instantiated. So again, if you look at the create world empty object, we should have a placeholder. If I click once on it, we should have a placeholder called a wall, and then I will need to drag and drop my prefab onto this placeholder. So now we should be ready to go. And if I play my scene, you should see that I've got a row of cubes. Here you go. You can see that. So again, the space between them is about 1. Okay, so again, by using the multiplicator in the vector tree, we managed to create a bit of space between them. So what I'd like to do now is can have 10 rows of 10 boxes. So again, the principle is the same. The only thing is that I'm going to create a loop within the first loop. So again, we're going to go from 0 to 10 on the x-axis and from 0 to 10 on the z-axis. So to be precise, 0 to 9 and 0 to 9 again. Okay, we have 10 elements on the x, 10 elements on the y, on the z, sorry. So again, same again, we just use a similar code. The only difference is that we will need to change the z position. So again, the y is the same, but the z will be j multiplied by 2. So we need to change that. It should be multiplied by 2. Multiplied by 1 or j on its own should be okay. However, to make it a little bit more balanced, it will be better to use the same space as for the x-axis. So again, if you play it, you should see about 100 boxes. That's it. But because there are no spaces on the z-axis, you can't really see the difference. So again, what I will do is go back to the code and multiply by 2, j multiplied by 2. Okay, so again, we're going to save this script, go back to Unity, play the scene, and then what you could see is 100 boxes. So again, it is a very handy way to create an environment, and we will see in a few seconds that you can also use arrays to customize all of that. So now that this is working, what we'd like to do is use an array to be able to create some kind of maze, but this maze will be generated only from a script. So what I will do is create an array, and again this array will be two-dimensional. So again this array will have, we can compare this I suppose to a building with different floors, and on each floor different apartments. In this case we have a two-dimensional array. So in my case what I will do is just define what is in this array. So to define this array again, you can see that you have the square brackets and a comma in between, so we just have two dimensions. And again, each of the actual rows of the arrays are defined as follows. So again, what we'll do is just put a series of 1 or zeros. So the plan is that for each one in the array, we'll put a box, and for each zero, we'll just put nothing. So if you look then at the full array, as you will see it in a few seconds, what you should see is that it just kind of describes, it will describe the shape of the outside walls of the maze. So again here, I'm going to change the first line to include only ones, and the last one will be the exact same. So again, what we have is our first row is just ones, and the last row is one. So if you look at this array, it looks basically like it's kind of the outside walls of a maze. So what I need to do is change my script slightly, and for this script what I want to do is only instantiate an object only if at the corresponding position of the y and j for the loop we have a 1. Okay, so again we instantiate a box only if the corresponding number in the array is 1. And with this very little change, very subtle change and little change, what we could do is just start to create our maze based on the array that we have just created. So again, I'm just wrapping a bit of text for you there, telling you that we'll create a wall at this position only if the corresponding value in the array is 1. So after this, we should be pretty much okay. We just save our script, go back to Unity, and then we have just a few small little errors. So again, let's go back to our code. So what we could see is that here I misspelled. So again, it should be word map. Okay, and the second error is that I'm actually defining the variable t within the statement, and I need to do that outside. So again, if I go back to my script here, I can declare the variable t before the conditional statement. So again, I'm going to say GameObject t, so to define t as a GameObject, and then use it in a conditional statement. So again, what Unity is telling us is that you can't declare an object within the conditional statement. So again here, I'm going to remove GameObject and keep t. So once this is done, then I'm going to save this script, and we should be pretty much okay to go. The console window should clear up and only display 1 or 2 warnings. That's it. Okay. So again, if I save this code and I go back to Unity and press play, what we should see is the outside walls of a maze. Here we go. So that's done. So this is a reflection on the actual array that we've created earlier. So what we could do now to make it a little bit more fun, we could just change a few values in this array to basically define the maze and define corridors or more walls. So again, I'm just making very small changes, saving my script, pressing play, and then if I go back to Unity, you should see that it has created a maze for which the outline is very similar to what I have in the array. So again, play, and if you look at the maze right now, you should see it exactly. So now the only thing is that you have a bit of space between those boxes. So again, if you wanted to create a real maze, we could change the y and j parameter just to leave I, so to remove the multiply by 2, which means that the boxes will be much closer, and we will have effectively a maze. And again, I'm going to make some more changes in the array, and again, you should see that these changes are reflected in the actual outline that is created or instantiated in Unity. So again, changing this value, saving our script, and then going back to Unity and playing. That should work as well perfectly. And after playing the scene, you could see exactly, you should see the maze right now. As you can see, they are much closer now. And we have defined some kind of maze. Again, it's very simple. You can always make it more complicated, but that's the principle. That's it, guys. I hope you really enjoyed this tutorial. Again, if you want to know more about Unity, please check the website www.learntocreategames.com. See you. Bye.